This is the SPC example handout that I posted on Blackboard. I'm gonna solve it here with the voice over the handout so you can play it back and get the details of how it's solved. This is the steel handles example. We took 5 samples, and in each sample we took 4 observations, and we weighed these observations. We weighed these handles. So for the first sample, the first handle was 10.2, the next one was 9.9, then it was 9.8, and then 10.1. So we have 5 samples, and n, the sample size, is equal to 4. So we go look at the table in your book, and we look it up in n equals 4. The table assumes that sigma is 3 standard deviations. So that's the z in other tables is 3. And we find that A2 is equal to 0.73, D3 is equal to 0, and D4 is equal to 2.28. So that assumes that the lower control limit and the upper control limits are going to be 3 standard deviations from the mean. So first we have to find the center limit. And so the center limit, the center line, CL, is always the average of the measure. We have 2 measures because this is a variable chart. We have an X-bar measure, which measures the average, and we have an R measure, which measures the range, like the variance. So we start with the X-bar chart. X-bar is the average of the sample. So we take 10.2 plus 9.9 plus 9.8 plus 10.1 and divide it by 4. We get 10. We do the same thing for sample 2, 10.3 plus 9.8 plus 9.9 plus 10.4 divided by 4, and we get 10.1. You do that for all 5 samples, and you can do that with a calculator or with Excel, and you get these numbers. We do the same thing for the range. The range is the max minus the min. So for sample 1, the max is 10.1 and the min is 9.8. 10.1 minus 9.8. The max is 10.2 and the min is 9.8. 10.2 minus 9.8 is 0.4. So sample 2, the max is, it looks like 10.4 and the min is 9.8. So what's the difference? 0.6. And so on. You do that for all samples. So this is going to be 0.6 and 0.6. So once you do that for all samples, then you know that the center line is always the average of the measure. So for the X-bar chart, it's going to be the average of the average. The average of the X-bar, the grand mean, if you will. And for the R chart, it's going to be the average of the R. So that means you're going to take the 10 plus the 10.1 plus 9.9 plus 10.2 plus 10 and divide it by 5 samples. So that's going to give you 10.04. And then you do the same with the R. You're going to take 0.4 plus 0.6 plus 0.4 plus 0.6 plus 0.6 and divide it by 5 samples. You're going to get 0.52. So there you go. You got the center line for both charts. So if we come here to summarize, we have an X-bar chart here, and we have an R chart. We have to make sure that both are in control for this chart, this process to be in control. So we know already that the CL is the X bar bar, and that was 10.04. Here we know that the CL is equal to the R bar, and that was 0.52. From the formulas in your book, we know that the UCL here is equal to X bar bar minus A2 R bar. So that is going to be 10.04 minus, and we found here the A2 and D3 and D4, so minus 0.73 multiplied by R bar, which is 0.52. So if you calculate that, you get 9.66. And so that's my second measure. And the lower control limit is going to be subtracting. Sorry, this is UCL, so you add. This is LCL. This is LCL, so that was the lower, and this is UCL. We're gonna add them, so this is plus A2 R bar. So LCL is subtraction, UCL is addition. So now 10.04, and now we add A2 R bar, so A2 is 0.73 multiplied by 0.52, and so this is going to give you 10.42. If lower control limit is ever negative, less than 0, you make LCL equal to 0. So if it's ever negative, it doesn't make sense, you have to make it equal to 0. So that's how we calculated. So here is CL, here is LCL, lower control limit, and here is UCL. Let's do the same for the R chart. Here is CL. The LCL for the R chart is D3 R bar. D3. So this one is a little bit different than the X bar chart, where once we subtract and once we add. Here it is 0 times R bar, which is 0.52. 0 times anything is 0. And the UCL is going to be D4. So here D3, here D4 times R bar. So that's going to be 2.28 times 0.52. So that 2.28 times that is about 1.19. So to know whether they are in control, if the chart is in control or not, we have to draw the chart and we have to draw the sample. So for the X-bar chart, you can come here and everything is relative. So here it would be the sample. We have 5 sample, and this is X-bar. So you can look at sample 1, 2, 3, 4, 5. And then you can do your CL is 10.04. Again, you're just looking at relative 10.04. And then LCL is 9.66. 9.66, and UCL is 10.42. UCL is 10.42. So then you come and draw these numbers right here, all the X bars. The first one is 10. That's going to be slightly under the CL. The second one is 10.1. That's going to be slightly above. The third one is 9.9. That's going to be below here, 9.9. The next one is 10.2. That's going to be above that, almost midway. So that's 10.2. And then the next one is, so the last one is going to be 10, but the first one was 10. So we line it up with this. So that would be here. And then we connect the points. So it looks like the X bar is in control, because all the points are within the LCL and UCL. Now for the R chart we do the same. Here is the R, the measure is R, and the sample again is on the x-axis, 1, 2, 3, 4, 5. And so we CL is 0.52. So we say this is 0.52. LCL is 0, but that's the x-axis, so we emphasize that LCL is the x-axis, and UCL is 1.19, so we say this is UCL. And we don't have to draw all the points to know that all the R's here are within control, because you have all these numbers are within 0 and 1.19. So one way to do it is to draw like we did with the X-bar chart, and the other way is to just compare the number and see if they are within your LCL and UCL. Well, they are obviously within 0.52, within 0 and 1.19, so we can say they are within control. So since the X-bar chart and the R chart is within control, we can say that this process of making steel handles is within control. You can definitely go ahead and graph it, but it's really not necessary, because the criteria we're gonna use in this problem is if all the points are within LCL and UCL, we're gonna say that it's within control. But to complete the problem, here's the first sample, 0.4, 0.6 is above the line, 0.4 will line up with the first one, 0.6 will line up with this one, and 0.6 again will line up with this one. So we have a graph like this. So this one is also in control. So since X-bar chart and R chart in control, we can conclude that the process is in control. Again, you don't have to draw. If you don't have to draw, you can just look at the numbers for the X-bar chart and make sure that the X-bars all lie within LCL and UCL, and look at the R numbers and make sure that they are within the LCL and UCL of the R chart, and determine if they are in control or not. In the real world, you will have to use more criteria than that. You have to make sure that the numbers are bouncing nicely, and so you have to do some pattern testing and make sure that there is no pattern. The numbers are not just going up, 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 or going down, 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 but that's more advanced than this class, so we're not going to talk about it. Okay, and that does it for this problem.